In this video, I'm going to demonstrate how to solve multi-step linear equations with variables on both sides. The learning target is that I can solve a multi-step linear equation with variables on both sides. The language target is that I can do this when, provided with a multi-step linear equation with variables on both sides, I identify the variable terms, I identify the constant or numerical terms, I move the variable terms to one side by adding or subtracting, I move the constant terms to the other side by adding or subtracting, and then I isolate the variable by moving what is furthest from the variable first, using inverse operations in order to isolate or get the variable completely by itself. I know I've completely solved when I can write my final answer as a variable equal to a constant or number. The specific example shown in this video will demonstrate how to solve when combining like terms is not required as a first step. Prior to beginning my work, I always want to make sure to read the directions. The directions here say to solve each equation. Let's take a look at example 1. As always, I highly recommend clearly dividing both sides of the problem by drawing a line down the middle of the equal sign. That helps me to keep the equation balanced and ensure that whatever I do to one side of the equation, I also do to the other. Next, I scan the problem to identify if there are any like terms. I'm noticing a number and a variable term on the left-hand side. They do not go together because they are not like terms. They do not have the same variable in power. Looking on the right-hand side, I see a similar situation, only a variable term and a constant or number. Therefore, I can move to my next step, which is to determine one side to put the variables on and another to put the numbers on. In this particular case, I know that if I move a negative 6n to that side, I will end up with a positive value, which is kind of what I want. If you're more comfortable with always moving the variable terms to the left-hand side and the constant or numerical terms to the right-hand side, then that will also work as well. But for the purposes of this lesson, I'm going to demonstrate the strategy that will allow you to solve in fewer steps. So that I don't forget what I'm going to do, I'm going to write a large V up above the right-hand side and a C up above the left-hand side to remind myself that I want all my variable terms to move over there and all of my constant or numerical terms to be moved over there. As a reminder, when moving things from one side to the other of the equal sign, in this case, when I want to move the entire term, I must only use addition or subtraction, not multiplication or division. Let's go ahead and move the variable terms first. If I want all the variables or letters over here, that means I need to take this negative 6n, remember the negative belongs to the 6, and move it over to this side of the equation. Since it's a negative, I know that I need to add it to undo it. So I'm going to write add 6n immediately under the negative 6n. When I go to write that add 6n on the other side of the equal sign, I could either write it here in spot 1 or here in spot 2. I'm going to choose to write it in spot 1 so that my like terms are lined up, because I know that I can combine n's with n's, but I cannot combine that n with a negative 2. Now I'm ready to do some math, so I'm going to draw a little equal sign. As I simplify from left to right, I notice first that I see a negative 16. Since I didn't write any math underneath it, I'm simply going to bring it down by writing it again. Next, I'm asking myself what negative 6n added to 6n equals, and it is 0. Those terms cancel out, which is exactly what I want to happen. Now I write the equal sign. Right here I need to remind myself that what I have up at the top is a 1n, and I'm going to add 1n to 6n. The result is 7n's. I must not forget the variable. Next, I'm not doing any math with that subtraction by 2, so I'm simply going to bring it down. From here, we can follow our steps in solving a two-step equation. I know that the end result is that I want this n to be completely by itself. So the negative 2 needs to move to the other side, and so does the 7. I'm going to move what is furthest from the variable first. As I'm scanning, I'm noticing the 7 is too close and tightly attached, but the negative or subtraction by 2 is further away. In order to move the subtraction by 2, I'm going to add it. Whatever I write on one side, I must write on the other. As I simplify from left to right, I'm doing calculator work on the left-hand side there. It tells me the result is a negative 14. I write the equal sign. There's no math to do yet with the 7n, so I'm just going to write it again, and negative 2 added to 2 is 0. Lastly, I need to undo this imaginary or invisible multiplication that's happening there, 7 multiplied by n. The inverse or opposite of multiply is divide. I will divide both sides by 7 because that's what's attached to the n. On the left-hand side, I have a negative 2. And then on the right-hand side, 7 divided by 7 is 1. So what remains is a single n, which is exactly what I want. Lastly, in order to make sure my answer is clear from my reader, instead of writing negative 2 equals n, I'm just going to reverse the direction and write that n is equal to negative 2. We've successfully solved. We could check our work, but I'm not going to demonstrate that in this particular video. Let's take a look at question 2. Once again, I recommend clearly showing left side and right side. As I'm looking at the numbers this time, I know that if I move this variable term onto that side, the answer will then be a positive result. So this time I'm going to decide to move the variable terms onto the left side and the constant terms to the right, which is probably what most people are comfortable with. That means I need to take this negative 3n and move it to the other side. As a reminder, my only two options for moving all of the term are adding or subtracting. I'm going to write adding 3n since it's negative. Whatever I write on one side, I must write on the other to keep the equation balanced. I'm seeing a negative n here, so I'm going to write my adding by 3n immediately underneath it so that my like terms are lined up. As I work from left to right, I notice I'm not doing any math yet with the 15, so I'm simply going to bring it down. And I know what's coming next, so I might need a little bit more room there. Next, I'm going to add these two together. Negative 1n, that's a negative 1n, added to 3n, is a positive 2n. Next, I'm going to write my equal sign, not doing anything with that positive 1 yet, and negative 3n added to 3n is hopefully 0, which is exactly what we wanted. You'll notice now all my variable terms are on the left-hand side. From here, it's a two-step equation once again. In looking at these two numbers, I notice that 15 is further from the variable, so I'm going to move it first. I have to remind myself that it's an implied positive, so in order to undo it, I must subtract 15 on both sides. Whatever I write on one side, I must write on the other. 15 take away 15 is 0. I'm not doing anything with the 2n yet, so I'm just simply going to write that again, write the equal sign, and then 1 take away 15 is negative 14. My last step here is to undo that invisible multiplication by dividing. Once again, whenever I write on one side, I must write on the other. When I do 2 divided by 2, I have a single n. And on the right-hand side, negative 14 divided by 2 is negative 7. N is equal to negative 7. Let's take a look at example 3. This time, I have some like terms that I need to combine on the left-hand side before moving to the next step. I skipped this on number 2, but we should always be looking to see if there's anything that we have that can get combined. Notice that on the right-hand side, the b term and the number are not going to get combined because they're not alike. But on the left-hand side, these are most definitely going to get combined together because they both contain b's with an exponent of 1. I must use the same signs if I'm working on the same side. So negative 3b take away 5b is negative 8b. I'm not going to add them together. I didn't move across the equal sign or over the equal sign. I simply combined on the same side, so I used the same signs. And I didn't do anything with this negative 5b and positive 12 yet. At this point, I need to determine a side for the variable terms and a side for the number terms. Now, in order to make my variable terms positive, I would have to move the 8b here, but then at that point, I'd have to then move the 12 over here, which would be more steps than I'd probably like to do. So what I could do instead this time is take this term and move it over here, recognizing that the result will be a negative coefficient or negative number attached to the variable term, but that's okay. So let's put the variable terms on the left-hand side and the constants on the right. That means I want to take this negative 5b and move it to the other side. As a reminder, my only two options when moving entire terms are adding or subtracting. And since it is a negative term, I know I must add it in order to make it move to the other side. Whatever I write on one side, I must write on the other. Now I'm ready to do some math. On the left-hand side, I know these two go together because they both have b's with an exponent or power of 1. I'm going to write that calculate that. It is negative 3b. Now I'm going to drop the equal sign down. Negative 5b added to 5b is 0, which is exactly what we wanted to happen. And then I have a 12 remaining on the other side. Lastly, I need to remind myself again that this is negative 3 multiplied by b, so I must undo it by dividing both sides. I must divide both sides by the number that's currently attached to the variable that's called the coefficient. Notice if we did not divide by a negative, we wouldn't truly be able to get rid of the coefficient or turn it into a 1. But because that's the same thing on the top and bottom of the fraction there, I know it equals 1, and I'm left with a single b equal to, on the right-hand side, I'm calculating that, and the result is negative 4. b is equal to negative 4. Let's take a look at example 4. Once again, I want to clearly show left side, right side for my reader. I also want to check and see if I can combine any like terms. Well, I'm noticing that if I'm just looking at one side at a time, there aren't any like terms to combine. Remember that we can never combine like terms over the equal sign. That's a big no-no. We must always use inverses or opposites if we want to move things from one side to the other. Next, I need to determine a side for my variable terms and a side for my constant terms. Once again, I know that if I move this over to this side, then I will have a positive coefficient, which results in fewer steps overall. So I'm going to take the negative r and I'm going to add it. It's a negative 1r. Notice where I write it on both sides, making sure my like terms are lined up. On the left-hand side, I'm going to simplify from left to right here. So negative r added to r is 0, which is exactly what I wanted to happen. I'm not doing anything with the 2, so I'm going to write it again. I'm also going to write the equal sign. On the right-hand side, I'm doing 2r added to r, which is 3r. And then I'm not doing anything yet with this negative or subtraction by 7, so I'm simply going to write it there. Now it's a two-step. I know that I want the r to stay and everything else to go away. I need to move the negative 7 to the other side and the 3, but I will move what is further first. The negative 7 is further and easier to move first, so I'm going to add it on both sides because I'll undo the subtraction by doing addition. On the left-hand side, 2 added to 7 is 9. Going to write the equal sign. I'm going to drop this 3r down, just write it again because there's nothing to do with it yet. And negative 7 added to 7 is indeed 0. Next, I know I want to undo this invisible multiplication by division because division is the inverse of multiplication. On the left-hand side, 9 divided by 3 is 3. On the right-hand side, 3 divided by 3 is 1, so I have a single r left. Once again, instead of writing 3 is equal to r, I want to make sure my final result is clear to my reader. So I'm going to write r is equal to 3 and box it to show that that's my final answer. And that's how you can solve simple multi-step equations with variables on both sides.